So it took 9 years just to draw the map. Have you had any time to look at it to see where this map could take you?
Yes, that's right. So after we kind of drew the map, I then spent the next, about 3 years, I would say, actually analyzing it. I worked with collaborators at Johns Hopkins University, and we applied network statistics to it, and also looked at how information flows through the brain, as well as comparing it to other networks, for instance, artificial neural networks.
And can you make a correlation between what's going on in the fruit fly brain and maybe the human brain?
Yeah, so I think the fruit fly larva is kind of this sweet spot where it's small enough where we can map it, and we can now do these extra bits like look at how gene mutations change the brain or environmental factors that change brain structure. But it's kind of in the regime where it looks similar to human brain. So it has a left and right brain hemisphere, it has a memory and learning center, it has a brain stem-like structure. The brain connects to what's called the ventral nerve cord, which is kind of analogous to the human spinal cord. So we can really follow sensory signals into the brain, understand what computations are being performed, and which behavioral signals are sent to that spinal cord or fluid, which then control muscles. So we're really getting into a state with this animal where it's starting to look a bit more like the human brain. So I'm hoping in the future, as we understand more about this brain, we can make some more direct comparisons with how brains of larger animals actually perform computations.
So with the computation, though, I'm a little concerned about how much of your life is going to go into this. I mean, you mentioned 80 people working, 11 human years combined to map the tiniest brain I can think of. And if we're going to extrapolate that further and go into more detail, is there some way you're going to do this faster to scale up, like with machine learning or some kind of technology to help hasten the process?
Yes, that's right. So in this current project we're talking about, it started about 10 years ago. So we were using technology that, by today's standards, is a bit out of date, both on the microscopy side and on the analysis side. So in terms of microscopy, the actual microscopes we used, as I mentioned, it took over a year just to image the brain and not even start generating that wiring diagram. But now, new microscopes allow us to now image a similarly sized brain in a couple weeks instead of over a year. So this is a huge reduction in effort. And then once we actually have the data set to reconstruct the synapses and the neurons, that took, as you mentioned, about 11 person-years combined. But now with artificial intelligence on the rise, there's now algorithms that allow you to automatically detect synaptic sites between neurons and also identify the shapes of neurons and how those neurons are connected to each other. These algorithms are still in development. They're not perfect. People still need to be involved and have to proofread the outputs of these things, but it really changes the game a lot. So we would go, I would suspect, from 11 years reconstruction time to a matter of months.
Well, thank you so much. I mean, I've asked the others because we've been talking about brain emulation and uploading your brain and downloading your brain. I want to know, would you want your personality uploaded or backed up?
It's a tough one. Today I would probably say no, but that could change as time goes on. I think we're a long way away from that at this point in time.
Do you think that your work's got us closer? Is it a step closer?
Yeah, we're absolutely a step closer. I mean, I think getting these wiring diagrams is a huge step closer, and this one is kind of the largest published one now, but I think it's really a stepping stone to larger and larger ones. So for instance, the adult fruit fly brain map or connectome, that will be coming out this year, I believe, and that one will now be another order of magnitude more complex. And so I think as technology gets better, as machine learning algorithms get better, so we can process this data better, I think we can get to the state where we could do a mouse brain and larger, for instance. When we can get to a human brain, I don't know, but I think it's no longer completely science fiction.
On that note, we say thank you and goodbye to Dr. Michael Winding from the Francis Crick Institute in the UK. Thank you for coming on the show.
Oh yeah, thank you for having me. It's been a pleasure.
We were going to give Michael a round of applause.
Oh yeah.
But we just thought he might get really embarrassed. And look, we've covered a lot of controversial topics so far. Should we all have neurological privacy? Would it be useful to know what's going on in each other's minds? Listeners, you can upload your thoughts to unexpected@bbc.co.uk, or you can WhatsApp us on +44 330 678 3080, or write to us. Unexpected Elements, BBC World Service, Cardiff, CF10 4GA in the UK. Still to come on the show. Is it a bird? Is it a lost bird? Is it a spy bird? We do a little digging into the world of animal spies, plus body art and science combined. We look at the tattoos that might also tell you when your body's not on top form. More Unexpected Elements coming up shortly. This is the BBC World Service, following mothers across the world.
Imagine going away to another country because you have a child and you need to support them.
I left in the middle of the night. As I walked away, I couldn't hear my children cry.
And when you get there, you get a job as a nanny.
You wash them, you give them food, you play with them.
You're spending all your time with children, but not your own.
I treat them as my own children. I give them unconditional love.
And when you're taking care of other people's children, who's taking care of yours?
I am talking to them every day. Physically, I'm away, but emotionally, mentally, I'm there.
I'm Namilansa Kombo. I wanted to make a space for some of these women to tell their own stories, to tell us what their world is like, the sacrifices they made, and their hopes for their families.
Other People's Children at bbcworldservice.com/documentaries or wherever you get your podcasts. Coming up after the news, is it a bird? Is it a lost bird? Is it a spy bird? We do a little digging into the world of animal spies, plus body art and science combined. We look at the tattoos that might also tell when your body's not on top form. And talking of sensors, we build some powered by the energy of specific sounds. That's more Unexpected Elements coming up shortly.
BBC News with David Harper. The government of Trinidad and Tobago is considering whether to declare a national emergency over an oil spill which has polluted a large stretch of coastline. Specialist divers have been trying to plug a leak from a wrecked vessel. About 1,000 volunteers have joined the cleanup effort along Tobago's southwest coast. The Hungarian president and a former justice minister have resigned in response to public outrage over the child sex abuse scandal. They pardoned the deputy head of the orphanage who'd been jailed for covering up the crimes of his boss. Both women are close allies of the Prime Minister Viktor Orban. Myanmar's military rulers have announced compulsory military service for all young men and women. In recent months, the army has suffered defeats by ethnic militias and other opponents of the military government. Voters and politicians in Pakistan are still awaiting the final results of Thursday's general election. There have been warnings of protests unless they're published shortly. The jailed former Prime Minister Imran Khan and his rival Nawaz Sharif are both claiming victory. Israeli police have clashed with demonstrators in Tel Aviv who demanded the government do more to secure the release of hostages still held by Hamas in Gaza. 3 soldiers from the United Arab Emirates and 1 from Bahrain have been shot dead in Somalia. The UAE's Ministry of Defense were training Somali troops in Mogadishu, one of whom opened fire. The chief executive of one of Nigeria's biggest banks has been killed in a helicopter crash in California. Herbert Wigway died along with his wife, one of his sons, and 3 others. King Charles has expressed his thanks for the messages of support and good wishes he's received since it was announced that he's been diagnosed with cancer. And in football, South Africa beat the Democratic Republic of Congo 6-5 on penalties to take 3rd place in the African Cup of Nations. The final takes place on Sunday with Ivory Coast facing Nigeria. And that's the latest BBC News.
This is Unexpected Elements from the BBC World Service. I'm Marnie Chesterton in Cardiff, Wales, and on this week's panel is...
Kai Kupferschmidt in Boston, Massachusetts.
And...
Chavi Sachdev in Mumbai, India.
This is the show that looks for the science within the stories hitting the headlines. So we get through a lot of headlines. And next up, Chavi is bringing us a story deemed under the radar. So it's a chance to share a story that some of us might have missed.
And here's an audio clue. All right. I think everyone, everywhere, has some kind of alarm or sensor around them, right? Whether it's monitoring you or your body functions or something external in the world. And, you know, they all constantly need power so that they can work.
Right, and I've just upgraded the smoke alarms in the house. So they no longer rely on batteries, but for some reason the stupid things that are now connected to the mains beep at me at least once a day. I think I prefer the battery version, but then you've got to worry about them running out.
Right, and also the batteries themselves. In India, we're supposed to be recycling our batteries, but it's a fact that a majority of the spent batteries end up in landfill. And closer to you, in the EU, as many as 78 million disposable batteries will be spent daily by 2025. Yeah, that's a lot. Yeah, so coming back to sensors, most do have tiny batteries built in. Some of them can be charged, but some sensors, especially when they're positioned in a remote or difficult location, like if they're placed under a bridge structure to check if the bridge is sound, or listening for gas leaks in old oil wells, they can't be checked or changed often, and their batteries need to be replaced before they run out, right? So, new on the radar is a type of sensor that can power itself, simply from the energy and sound waves. And the secret ingredient is fresh development in metamaterials.
So I had to look up metamaterials, it's a new one on me. And these are materials that usually work with light energy rates, and their surface is designed at the nanoscale to give that material very special physical properties.
Exactly, so not the chemical properties, but the physical properties of these materials. But these ones, they work with sound rather than light, and they can be made to recognize really specific sounds while ignoring other ones.
Okay, like different frequencies of sound.
Actually, different words. The scientists at UGH Zurich have modeled metamaterials that can give off a small electrical charge when they hear the word for, rather than two or two or one. The material then converts the energy in the sound wave into a very small charge current, which could be used to power a sensor itself or to charge a tiny battery. Some engineering thought is still needed to design sensors for different situations, but the principle opens up so many possibilities.
That might be the most amazing thing I've heard, that you can actually model a material so that a specific word or phrase triggers it to get a charge. That's astonishing. And so this applies to sensors that are monitoring sounds, but not everything that needs monitoring actually makes a distinctive sound.
Well, it can also charge up just the alarm power, but more things than you think make sounds. For example, a bridge cracking over time would make a certain sound, and an oil well that's releasing methane would emit a distinctive hiss. So if your metamaterial sensor was designed to function only to pick up that sound, then it would do its job, and the signal of concern would also power the alarm when it needs it. And what may be even better, say with the bridge example, if you could power the battery from the noise of the cars passing over, a different part of the sensor could be continuously monitoring for a cracking noise in concrete.
That is so clever. And I mean, it sounds like it's a good idea for the huge number of rusting batteries that we leave lying around.
The team have done quite a lot of background work, and they reckon that they could have a prototype of a zero battery sensor by the end of this year.
Ha! So, a sci-fi concept, but actually, unlike the uploading your brain, it sounds like this one might be actually workable in our lifetimes. Kai, have you come across metamaterials?
I have actually, Marnie, and in another sci-fi concept actually. So there's metamaterials that basically manipulate light in a way that they make the idea of an invisibility cloak a possibility, right? I mean, things that have actually been done are like absolutely tiny examples of this, and they only work at a certain spectrum of the light, say microwaves. But it is kind of fascinating what these materials can do.
I'm still buzzing about the idea that you could design a material to be charged by the sentence, Marnie Chesterton is awesome, and then people would have to say it every so often just to keep the sensors sensing. Well done.
Well, if you have a crying baby at home, you might be able to have no electricity bill whatsoever.
That would be amazing! Parents everywhere suddenly thinking, okay, this is actually a useful resource. Thank you both. Thanks, Xavi. Now, talking of sensors, Kai, Xavi, do either of you have a tattoo?
Several.
Oh, what have you got?
It's a very extensive list. Let's just say there's many.
Okay. Kai, have you got one?
I don't have a single one. I've been carrying around an idea for one for years, but it's like the idea that there's anything that I won't look at in 20 years would be like, well, I guess my brain has changed and I don't like this anymore. It just kept me from doing it.
So what would you say if I told you that you could have not only a work of art, but one that could also tell you about what was going on inside your body? I mean, it's art, it's science, it's double ticks. So, Unexpected Elements reporter Katie Thompson went to a lab in London to find out more.
So the human skin is the largest organ in the human body, yet it's the least explored. And this is the first attempt to functionalize it as a dynamic display to reveal information about the human body. Initially, this project was entitled The Dermal Abyss.
The abyss is so ominous. I'm sat down with Dr. Ali Yassin at Imperial College London in the Department of Chemical Engineering to find out more about biosensors.
So I lead the laboratory for biochemical sensors. What we are trying to do is to design continuous or real-time sensing technologies to build a bigger picture of the human condition.
I'm in Ali's lab right now, and it all looks pretty standard. We've got workbenches and test tubes and lots of busy students working away on various sensors. But there's something a little bit out of place to the left of me, Ali, and that's a tattoo gun. Why do you have one of those in your lab?
Right, so this is an amazing project, and we are working with tattoo artists in order to design new types of diagnostic technologies that can be injected inside the human body. So what we are trying to do in our lab is to re-engineer these conventional inks. So it's just like having a regular tattoo, but the difference is that these tattoos will change their color in response to certain biomarkers. For example, it may be glucose or electrolytes or certain proteins in your body to reveal information about your body condition.
So right now, Ali is loading up the tattoo gun with some bright orange peachy ink.
Okay, so what we have here is an ex vivo skin model of pork skin, and we will be tattooing a color-changing pH tattoo. Alright, here we go. Now we start tattooing. So it's just going to be a gentle strikes, okay? You're doing.
That's amazing. So as you're putting that peachy coloured ink onto the skin, it's immediately turning this greeny blue.
Correct. Because the interstitial fluid has its own pH. So for that reason, it will immediately change its colour.
So you're manually shifting it up and down the pH scale right now with different solutions, essentially.
Exactly. And so we are trialing now the way a traditional biosensing ink will react in an actual environment.
So it's gone from very vibrant dark blue through to a greeny blue to now going almost yellowish in colour.
This shift can be simply correlated with changes in pH.
So why do we need new types of biosensors versus, say, wearable tech that we've got now?
So biosensing tattoos can be seamlessly integrated inside the human skin. So instead of using a conventional medical device that you have to carry around, biosensing inks can simply be integrated and injected inside the human body. And so you will basically carry your own medical device inside your skin.
That's pretty clever. Thank you to reporter Katie Thompson. The team haven't yet tested on a human, but assuming they do and it all goes well, Javi, would you get one of these?
Sign me up.
What augmentation do you want? What do you want it to do?
Well, I actually have real-world use cases for this. I would like to monitor my hypoglycemia, blood pressure, definitely. And I'll take all the parameters.
Just where would you put it though?
Like forearm? You know, in 2020, I remember looking at the prototype that was developed in a German lab, and that was like silver ink that changed color. And that I would prominently display because it was beautiful. This one maybe, I don't know, somewhere discreet, like the inside of my wrist or elbow or something.
Kai?
I would absolutely use this. I mean, actually it's more useful for the people around me probably. I need a flashing red light when I'm under caffeinated, and then people would know not to approach me.
Or I just have one on my neck that just says hug, and when I need a hug, it just sort of flashes up.
Or cactus, like stay away.
Listeners, what do you think? Who wants an augmentation? What would they get? You can email the show on unexpected@bbc.co.uk, or you can WhatsApp on +44 330 678 3080. You can even leave us a voice note there, like one listener did from Japan when we talked about why some people go grey last week.
Hello, good morning. This is Benon Nusra. I'm in Japan. I'm 60 years and I'm grey. I don't have grey hair yet, except for the beards. And I think I may trace it back to my grandmother, who was 85 years. My grandmother, mother to my mother, who died at 85 and didn't have grey hair. So it could probably be a genetic explanation.
And you lot write in with more than just comments. Sometimes you have a science mystery for us to solve, and we'll be tackling a juicy topic shortly after this.
It's Quizman Dan here, back to reveal the answer to this week's quiz question. Earlier, we looked at a study into mixed martial arts and asked you what researchers had found indicates that a fighter is more likely to lose a bout. A, if they smile at their opponent during the pre-match showdown, B, if they're right-handed, or C, if they're wearing red ring gear. Well, it turns out the answer is in fact A. The study found that fighters who smiled during stare-downs were more likely to both lose and be less hostile during the fight. It's not known exactly why this might be the case, but it's hypothesized that whether a fighter smiles or not gives a non-verbal clue as to how confident they are before a fight. If you got that one right, then well done. You've now got a black belt in scientific knowledge.
This is Unexpected Elements, and it's that time where we search through our inbox and pick out one of the scientific mysteries you've sent our way to see if we can lend a helping hand in finding you an answer in Ask the Unexpected. This week, our question comes from Fiona Preston in Lancashire in the UK, who asks, what are the nutritional benefits of freshly squeezed juice versus the cheaper long-life juice? Well, much like a lot of the fruit in our supermarkets, it's travelled the world, and we've gone round the world to find an answer.
My name is John Stephen Piper. I'm a clinician scientist who holds appointments as a consultant physician in the Division of Endocrinology and Metabolism at St. Michael's Hospital in Toronto, Canada, and a professor of nutritional sciences and medicine at the University of Toronto. So the benefits of a fresh squeezed juice would be really getting a lot of the bioactives, something like a vitamin C, for example, directly from the fruit before they've had a chance to oxidize and be lost. Some of that's lost in the processing of fruit juice. The fruit juice that you buy in a store, though, 100% fruit juice, is still an excellent source of nutrients, of vitamins and bioactives. But when you fresh squeeze it and you drink it immediately, you don't let it sit, because the longer you let it sit, you're going to lose those. You're going to get them at their maximal level. And I think the other thing to be said too, which is really important, is that's assuming the fruit that you're squeezing to get the juice is as optimal as the one that was used to prepare the store-bought juice, because there can be differences in the quality of the fruit. For example, a lot of people think that with frozen vegetables, fresh is always better, but frozen vegetables are often picked at the peak of season, so where nutrients are at their peak level. The freezing process is such that you don't actually lose a lot of nutrients, so they can actually have more nutrients than fresh bought vegetables, even from a farm stand. We see the same thing with fruit. A lot of the time when fruit juice is prepared or processed, they're picking the fruit at its peak in peak season, so it's going to have the maximal amounts of vitamins and bioactives compared to the one that you might have just grabbed at the store. So it's not necessarily the case that the fresh squeezed juice is going to be better than the processed juice. But if you hold that equal and you say that it's the same fruit, then yes, there is some deterioration of some of those bioactive components with time and with processing. So the fresh squeezed, if you consume it immediately, will have more of those nutrients.
Thank you very much, Professor John Siebenpiper, for that insight into the world of fruit and veg. Yes, we always come back to Fruit Chat here on the programme. And thank you to Fiona for sending in your question. I happen to have read a book called Squeezed, What You Don't Know About Orange Juice, which is, yes, very niche, but you will never look at the packaging the same way, because there's so many things that the court cases, the years of litigation that have gone into what you can and can't put on a label. It's absolutely fascinating. So what 100% pure and what orange juice versus orange means, it's that people have done more than thought. They've argued about this a lot.
I find labeling really interesting, especially when it comes to items like this, like cheese. I was just looking at my cheese packet, so I buy mine from a natural farmer. But you can also buy processed cheese, cheese foods, cheese-like foods, and cheese-based foods, and they all mean different things.
Well, my mum, who's a grammar pedant, that's a technical term, went round the supermarket with me once, pointing out that there were some sausages and they had quality written on them. And she said, well, what quality? She said, they haven't specified whether they're high quality or low quality, and therefore that is meaningless. And I was like, oh, that's actually a really good point. Kai, anything to add to the world of labelling before we move on?
I love fresh squeezed orange juice, and it doesn't really matter to me what the nutritional values are here. I just really enjoy a glass in the morning, and so I'd always go for that. And I have never had a store-bought juice that tastes anything like it.
Yeah. But I didn't realise, I mean, obviously when you think about it, it's like many fruits, it's a seasonal crop. But the lengths that you can go to, so the volatiles, the bits that smell most like an orange, are all in the skin. And you can do this process where you strip all of those oils out, and then you squeeze them, you keep all the juice in a vat for up to a year, and then just at the end you put the nice volatiles back in, and it's all fresh.